Question number 3. Figure number 7 shows how the national grid transfers energy from a power station to some street lights. In figure number 7, we can see the model. The power station, it generates electricity. We have two transformers, X and Y. The street lights are present here. To transfer the electricity from the power station to the street lights, we need national grid. In the model, we know that the national grid is going to help us to transfer the electricity from the power station to the street lights. 3.1 is an year 1 question. Explain how the transformer X increases the efficiency of the national grid. This question is from the topic of national grid. The student must know that transformer X is a step-up transformer, and the step-up transformer increases the potential difference and decreases the value of current. The reason behind it is if more current will flow through the cables, as a result of that, the energy is wasted in the form of heat in the surrounding air. Therefore, a large amount of electric energy is changed into thermal energy. Whereas the step-up transformer increase the power of the current by increasing the potential difference and decreasing the value of current. Let's see the model answer. The transformer X is a step-up transformer which increases the potential difference and reduces the value of current, which reduces the loss of energy in the transmission cable, means less energy is wasted in the form of heat. The marks distribution is already given here on the left side of the answer. 3.2 is an AO2 question, and this question is from the national grid. The potential difference across the primary coil in the transformer Y is 400,000 volts. The potential difference across the secondary coil is 11,000 volts. The current in the primary coil is 660 amperes. Calculate the current in the secondary coil of the transformer Y. A transformer consists of two coils. One is called the primary coil, another is called the secondary coil. So we need to use the concept of power. We know that the power is equal to current into potential difference. We have the potential difference across the primary coil, that is 400,000 volts. The current in the primary coil is 660 amperes. The potential difference across the secondary coil is 11,000 volts, but we need to find the current flowing in the secondary coil. We will use the formula power is equal to current into potential difference. Let's see the model answer. The power in the primary coil is always equal to power in secondary coil. We know that the power is equal to potential difference into current. We will use this formula for both for primary coil and for the secondary coil. Now we will substitute the values. The potential difference across the primary coil, the current across the primary coil. We're going to use the values here. The potential in the secondary coil, and we need to find the value of current in the secondary coil. After substituting the value, this 11,000 will go on the other side of the equation and it will divide the values. And the answer is 24,000 amperes. So the current in the secondary coil is 24,000 amperes. 3.3 is an EO3 question, and this question is from the topic of series and parallel circuit. Why is the current in each street lamp less than the current in the secondary coil in the transformer Y? We know that from the previous question, the value of the current in the secondary coil is 24,000 amperes, whereas the current flowing in each of the street lamp is quite less than 24,000 ampere. We need to find the correct answer. We'll consider here the current coming from the secondary coil here, that is 24,000 amperes, And if the street lamps are acting as resistor 1, resistor 2, and resistor 3, we know that they are in parallel circuit, therefore the current will divide. And the current here I1, I2, I3 is less than the total current I. So therefore, in a parallel circuit, the total current I is equal to I1 plus I2 plus I3. The correct answer is the street lamps are connected in a parallel circuit. Therefore, the current in the street lamps is less than the secondary coil. 3.4 is a combination of AO3 and AO1 question. And this question is from the topic of series and parallel circuit, resistors, potential difference, and the current. Figure number 8 shows the top of a street lamp. A light sensor is present and the lamp is present here. The light sensor detects if it is day or night. Figure number 9 shows part of the circuit in the light sensor. This is the power supply, a battery. A fixed resistor is present, and this is symbol of LDR, light dependent resistor. I drew my graph to help the student. If the light intensity is increasing or decreasing, the resistance of LDR changes along with that. If it is a daytime, the light intensity is high, therefore the resistance of LDR will decrease. If it is darkness or it is nighttime, the resistance of LDR is very high, therefore the less current will flow. The question is, explain what happens to the potential difference across the resistor R as the light intensity decreases. It means that as the light intensity decreases, we know that the resistance is increasing. Let's see the model answer, and we need to use this graph. This will help us to understand the question. As the light intensity decreases, the resistance of LDR is increasing. We can see from the graph. Therefore, the less current will flow through LDR because the resistance is very high at the night time or in darkness. Therefore, the less current will flow. So LDR will share more potential difference as compared to resistor R. It means that the battery needs to work more across the LDR as compared to the resistor R because LDR has more resistance than the resistor R. Therefore, it shares more potential difference as compared to the resistor R. 3.5 is an AO2 question, which is an application based question. A student need to apply their knowledge while solving this question. When the current in a resistor R is 20 milliampere, the power transferred by the resistor R is 6 volts. Calculate the resistance of the resistor R. This question is from the topic of power. We are already given the power is equal to 6 watts. Current is already given, that is 20 milliamperes, and we need to convert milliamperes into amperes by dividing it by 1000. We need to find the resistance of the resistor R. Let's see the model answer. From the equation sheet, we can find the formula power is equal to I square R, mean the current into resistance. The current is given 20 milliamperes, which we already converted at 0.02 amperes, and we need to scale it. The power is already given, that is 6 watts. This value will go on the other side and divide it 6 over 0.02 square is equal to R. By using the calculator, the value of R is 15,000 ohm. And the mass distribution is already given here.